Okay, welcome to the second Stockholm SIG Meetup. I guess that some of you may have been invited by Anders, or you have worked with him before. He's home with a sick child. Him and me, I'm Jonas, are arranging these SIG Meetups. And today we have a really nice schedule. We have two guests here who flew in today from the SIG Software Foundation. They are core developers, and they'll have two talks, and they'll be a little bit different. You can see them right here on the screen. Can I ask a quick question? How many in here are not game devs primarily? Wonderful, that's a good spread. There will be it will be possible to ask things about how SIG relates to game dev and how SIG relates to many other things. We're going to have a first talk here, and after that one we'll have a Q&A. And the first talk may be the right place to think of interesting questions and then ask them, because after the first talk in the Q&A we'll have food, which we thank our hosts here at the venue for. And then we'll have a second talk, which should be perhaps a little bit more technical. And if you want to pick our brains or just socialize afterwards, some of us will go to a bar nearby, and you're welcome to join if you want to. So that's the agenda. Any questions about that? No? Then you are very welcome, and I leave the floor to Loris.
Thank you. Please give it up for... Thank you. Okay, before I start, question. How many of you have never written any Zig code?
It's 5 hours now?
Well, okay, let's say less than 1,000 lines. Okay, then. Okay, so, okay, good, nice. So my talk is not going to be a waste of time then. It's an introduction to Zig, meant also to give an introduction to people who are not or yet part of the community. So 3 things you might like about Zig. So I'm Loris Crow. I work at the Zig Software Foundation. You can see there a bunch of social media stuff. I have a blog, christoph.it. I stream also on Twitch, and I have a YouTube channel dedicated to mostly Zig content. And also, some of you might be aware also, because I know that you were in Milan a couple of months ago. I run Software You Can Love, which is a conference. It's a little bit of a Zig conference, but also not only. And I'm setting up a softwareyoucan.love website. It's a work in progress. But if you go there, you will find like a very quick introduction to why the conference is called Software You Can Love. Instead of saying it's a conference about open source. What's up? It doesn't matter. It's fine, no worry. No, you're right. You can turn it off if you want. On the side. Pull it down. Yeah? No, you have to keep doing it. It doesn't want to die. Like it's trying to struggle, and then you have to... It's a timed event, like you have to keep pressing.
Oh, there we go.
Okay. Okay, so why Zig when there's already C++ and Rust? Well, I mean, I probably don't have to explain to you why C++ yes, why C++ no. Rust, I think it's a little bit more interesting. It's a new language, kind of like Zig. It's more further along. It's more developed, has a huge community. They do a lot of things very well. So why are we making yet another language? I think there is like one thing that Rust doesn't really do. And if I had to recap that into a single concept, I would say simplicity. Rust is not a simple language. There are good reasons why it's not a simple language, more or less, depending on who you ask. But the simplicity is, on one way, you can look at it from the perspective of writing code. In Zig, we strive to write simple code, somewhat in a similar way how you can contrapose C and C++. In some ways, it's very rough, but in a very rough way, you could say that Rust is to C++, how Zig is to C. There's like a bunch of asterisks once you get into the details, but from the perspective of simplicity, I think that holds roughly true. There's also another perspective when it comes to simplicity. So I said 3 things about Zig that you might like. So thing number 1, Zig is a cheat code for learning low-level programming and dealing with C and C++. So let's say that you don't know anything about lower-level programming and you want to get started. OK, so let's say that you want to start with C. So you get a C book or like a C manual of some kind. You want to start learning the language. But then also, you want to use some of the code that exists out there that has been written in C or C++. Like you want to use some libraries like you can in Python or JavaScript. OK, so your plan is to then getting started with C, try to find some libraries. That requires you to learn how to use make. But then, oh no, this problem has CMake, it doesn't have make. That one is using autoconf and CMake and make. Also, there's a PowerShell script in there somewhere. You're on Windows, so now you have also to deal with that. How many of you here use PowerShell, have to write PowerShell scripts? How many of you like doing it? I see a couple of hands. Let the record show that there were 2 hands that stayed up. OK, so some people said that I should use Ninja instead of make. Then there's that as well. Oh, but then my stuff doesn't build anymore. So like the caching, something wrong with it. I don't understand why. So I have to make clean. No, it's make this clean, right? Sometimes, not always, though. Also, this dependency, like this project needs Perl to build it to do the make step. This one requires Ruby. There's another one that requires Tcl. And you have to do this for every dependency of the dependency that you're building. So you wanted to start using C, and now you have to do all these things, which is not C. And that's not really simple. And that's another thing that Rust doesn't really tackle like directly. Obviously, Rust has a nicer building, has a build system, and it's nicer for building Rust. But Rust doesn't build C for you. Oh yeah, right. Also, then you try to compile it, and now there's a C++ template error, gigantic. You don't know what's going on anywhere, so you give up. OK, so the Zig toolchain. The Zig compiler it's a C, C++ Objective-C compiler. We wrap Clang, so it's like not a homebrew compiler, but at the same time, there's quite a few good things that Zig does on top of Clang to make it worth. Specifically, Zig bundles come on libcs, and that allows you to do cross-compilation, because if you're on Linux and you want to compile for Mac, or you know what, let's do the easier option. You're on Mac and you want to compile for Linux. Now you need a Linux libc. You probably need glibc or musl. And if you're just using plain Clang, you have to go fetch that yourself. You have to know that that's how this thing works, first of all, and then you actually have to do it. It's a lot of work. Zig does that for you. Like they come bundled with the Zig compiler. So you can just specify the target, and it's going to work automatically. You can use Zig as an in-place replacement for Clang. So everything that you're building right now that can build with Clang should build correctly with Zig. Keyword being should, mostly does, but you know, there's always corner cases. We also have our own linker to do things that Clang cannot do. There was a moment in time where the Zig linker could cross-compile, could create executables for Apple Silicon, for M1 Macs. LLVM couldn't do that at that point, and thanks to this guy. He wrote that linker, he's the main author, so you can chat with him about that later if you want. And of course, you can use Zig build to replace make, CMake, auto tools, blah, 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 all these soup of config files. This all comes in a 40 megabyte dependency-free tarball. So unzip, well, untar, set the executable to your path, done. And so once you do that, you don't have to depend on a system compiler. You don't have to depend on a soup of build systems. You simplified your build system as a starting point. And then from there, you can move forward with your exploration of either Z code or C code or C++, depending on what you want to do. Another nice thing of Zig is that it's nice to access C libraries from Zig. It's very easy. In this example, you can see that I'm directly importing the Raylib header file Raylib is a library that allows you to like open a window, get a rendering context, and draw stuff to the screen. And I'm importing the C library from Ray, and you can see that I'm directly accessing C functions. It's very easy. It's like right away. And you can build this by running zig build.exe, main.zig, link to libc, link to raylib. Obviously, it's not everything magical. You need to understand what it means linking to libc, what it means linking to raylib. So like you're not free from all the C complexity, but you're free from some of the craft. You're only exposed to the more, I would say, necessary stuff, like the more essential complexity. So let me see. OK, I'll punch this in all at once. OK, so you can directly import C headers. We have optionals. Optionals are nice, especially with pointers. They're really nice. We have a bunch of different pointer types that help you navigate the pointer complexity that you can be exposed from when using C libraries. Some pointers in C have a null terminator at the end. Some are, and you cannot easily distinguish a pointer to many items versus a pointer to a single item. These are all pretty clearly defined in Zig. And if you try to, for example, dereference as if it were a single item pointer, a pointer to many items, Zig will complain, will tell you, no, dude, you have to do square brackets 0 because these are many items, and vice versa. Vice versa is when things go bad if you get it wrong. So that's nice. Zig also has a nicer error system that makes it harder for you to ignore errors accidentally. And there's also these two nice keywords, defer and defer. So let's say that you have to create a resource, which could be allocating memory, opening a context of some kind. When you do that, and something goes wrong, you kind of want to roll back what you were doing, right? As if it were like a transaction. You got to step, I don't know, 3 out of 5, and you want to undo 3, 2, 1. Zig allows you to do that very nicely with the defer keyword. The nice thing is that this is not like a complicated trait, object, exception, I don't know what system. It's just calling functions. So you can do that on C functions. You actually saw me earlier use defer to close the raylib window. And that's a C function. So there's no weird integration necessary. That's pretty nice. If you have to write cleanup code in C, it's not as nice. So the result is that Zig is better at than C at using C libraries, which it's an interesting fact. But I mean, I would say it's kind of an objective truth. It's so nice to the point that I wrote this article called Maintained with Zig, where the idea is that, OK, some of you might see what I'm hinting at with the title, Maintain It with Zig. Maybe you heard something similar. Anyway, the idea is that instead of like rewriting everything, you improve stuff incrementally. You have an existing C project, C++ project, and you start by simplifying the build system. Get rid of the freaking build script soup as a starting point. Maybe turn it into a hermetic build, which is nice for reproducibility and avoiding weird phantom bugs on the executables that you deploy. And then from there, you can decide to, once you replace the compiler in place, once you replace the build scripts, then you can decide if maybe you want to also add a Zig compilation unit to your originally C/C++ project. Works better with C than C++, but you can do it either way. And I have an example, like there's a series of posts linked from that article where we actually do that for real with Redis. It's a key value cache/database for those who are not familiar. It's written in C, and we just add a new, after we go through the full process, and at the end we add a new Redis command written in Zig. It's super easy. But then again, I don't know, maybe you don't care. Just you can stop earlier, like you can just simplify your build nightmare and call it a day. OK, that's point number 1. Interesting thing number 2, Comptime metaprogramming. That one is pretty nice. That's what got me hooked originally. So can everybody read this? OK, so you want to create an array called foo and it has length 64, but you specify length as another parameter. That works. Actually, let me go back. That works. That works in C, that works in C, that works in pretty much every language. But let's say that now it's more complicated. Now, length is the result of a function call. This is a simple function call, but if you try to do this in C, good luck, it's not going to work. If you try to do this in Zig, actually, it's not going to work either, because it's going to tell you that it cannot, it needs length to be a constant expression, and it's not yet because it's a function call. And here comes a magic keyword, Comptime. You just say, OK, please run this while compiling. And at that point, it's going to work. And Comptime is your keyword. It's like your magic word into a bunch of metaprogramming stuff that is very interesting. Here's another example. You can use Comptime to define your own compile errors. So the idea is that you have this union. It's a tagged union, I believe. No, it's just a union. And for performance reasons, this is maybe something that interests game dev people more than others. But you want your union to be of a specific size, because you want it to be like cache line friendly. But there's always the intern who's going to add new fields while you're not looking and mess everything up. So what do? You add a Comptime check inside the definition that says, OK, unless we're in debug mode, and the reason for this check is because in debug mode, Zig adds a secret tag field that allows you to catch wrong field access, again, in debug mode. But if you're like making an actual release, like let's make sure that this union is as big as you want it to be and not more than that. So that's nice. Another example of a similar error that you can, or a similar compile error that you can make on your own is, let's say that you have this function called insensitive equal. It's a function where you test two strings for equality, and it has to be a case insensitive match. But for some reason, you know that one of the two arguments is known at Comptime and it's uppercase. This is a Redis thing. Like, I actually wrote this for real, because in Redis, commands can be uppercase, lowercase, they are case insensitive. So, OK, you write this, but now you want to enforce, right, the constraint. If you have a language with like diamond brackets, you have Java, how do you enforce this? You can't. Maybe in other languages you can do funky stuff. Macro in Rust, you can certainly pull that off with macros. What if we don't do any of that and we just use the normal language to do the obvious thing? We look at the string, the one that is known at Comptime, we check it character by character, and if we find a character that is not uppercase, we complain and we say, no, the upper argument must be all uppercase. And this is what happens when somebody tries to like misuses your API. They get a pretty reasonable error. They get the error that you specified, and they also get a like an error trace that tells them where it was invoked from. Pretty neat. So it's nice because you can test and enforce static properties of your code using the language, not using a weird subset of the language. And I don't know, it works. It's not perfect. There are some complexities that you buy into when using the Comptime. But it's pretty good. And it's, in my opinion, strictly better than macros. I love metaprogramming, and that's why I hate macros. Here's another very interesting example. This is another example that game dev people will appreciate more, I think, than most others, but still. OK, there's this funky function called apply operations. And it's like a list of operations, and each operation is like an enum case. Basically, starting from 0, the accumulator, we take an input number, and then apply this operation against the accumulator. And you can see that the operations are required to be known at Comptime. And then the for loop has an inline keyword in front of it. That inline has pretty much nothing to do with the meaning of inline in C and C++. But what it does is kind of force loop unrolling. And as we do that, we also can resolve the switch statically. So let's say that we have this example invocation where we ask the user for a number. So the number is runtime known, but the list of operation is Comptime known. So we call the function. And the result is that since we know that it's going to be sum, mul, sub, the for loop gets fully resolved, basically resulting into the actual list of operations here. And if you look at the generated machine code, that's exactly what lands in the final executable. That's pretty neat, in my opinion. Other things that you can do, generics. This is actually the boring part of Comptime. Sure, you can pass types around and you obtain generics. Although, look at the square root function. So this one is funky. In Zig, so okay, no, never mind. Look at the one on the left first. So linked list is a function that takes a type as input and returns a type. And that's kind of what a generic constructor does, right? It takes some arguments as input, usually types, and then produces a new type. And that's how you create a linked list of, I don't know, numbers, strings, whatever. Now you can see that in this second function in square root, the return type of this function is not a type, it's a function call. And the function call returns the type using the language, using Comptime introspection, type introspection to decide what to return. So long story short, what's happening here is that it's a square root. And if you run a square root on an integer, the resulting number, it's going to need half the bits to be represented all the time. That's what square roots do. And they can be represented in the type system. This is actually code that I've taken from the standard library. Like in the standard library, the square root function, you pass in an U64, you get back a U32. Maybe it doesn't matter. Most of the times, I'm guessing probably it doesn't matter. But the one time that it matters, it can be expressed. And it all starts from the ability to call a function where you're supposed to write the return type. Anyway, so yeah, Comptime is a unique way of achieving control over code generation without sacrificing high-level expressiveness. Like you don't have to mess around with, I don't know, assembly, macros, or whatnot. Thing number 3, the Z community. I just chose a few projects to quickly present for in case you find them interesting. So microzig is super cool. I think some people here, I know that Simon went to the workshop. You did, right? Oh yeah, Jonas also went. So they had a pretty cool workshop. So sorry, microzig is a framework for embedded devices. It allows you to write code for embedded devices using all the tricks that I showed you earlier, right? So metaprogramming so that the thing can automatically select the right register configuration for your specific embedded device. Inline for loops so that the thing is expressed nicely, but it doesn't produce garbage code in the final executable, which matters for embedded devices. It does all this stuff for you. And yeah, this is a photo from the workshop, so it's pretty cool. So that's one interesting project in Zig that really leverages the things that the compiler can do. Another thing is the Zig Game Dev project. This is from Michal Zulek. I hope I'm pronouncing this well enough. And it's so I'm not a game dev guy, but the way I understand it as an outsider is that it's a collection of, it's a toolkit of many tools that are bindings to existing popular libraries and other things that I believe people who do game development probably like. My impression is like people who do like AAA style game development might be interested in. This is like a list of all the things that you find inside Zig Game Dev. That's pretty cool. And it's always growing. He's working on it full time. So that's also really interesting. So also, if you check it out and you're interested, consider becoming a GitHub sponsor of Michal. Another one is Mach. This is from Steven Gutekunst. Again, not a game dev guy, but my understanding is that Mach has a little bit more of an indie vibe. I guess it's more like Godot-ish. Still, for game dev, that's another interesting project that you might want to check out. And the last one that I'm showing you today is Tiger Beetle. Tiger Beetle is a financial database written in Zig, and it does all kinds of cool stuff. So cool thing number 1, after it boots up, it never allocates memory. So it allocates, I believe, like about 4 gigabytes of memory at boot up, and then it never allocates. So it means that after that, it cannot be killed. It's impossible. It just doesn't allocate. That's pretty nice. That's something that helps with robustness, which financial services might appreciate. They also have their own. They're building their own distributed consensus protocol. They're not inventing it from scratch. The protocol is view stamp replication, but usually people tend to do Paxos and Raft. So they instead went for view stamp replication. I believe they have probably the best implementation out there today, and they have a very nice simulator that allows you to test to fuzz the entire system in a reproducible way, like in a deterministic way. So whenever the fuzzer finds a bug, based on the seed, you can always reproduce the problem reliably. And they have a bounty for bugs, like in case somebody finds a bug in the algorithm and everything else. And they have given out some prizes, not a ton though. Not because they are like not easily giving out bounties, they actually are. It's just that they are doing a really good job at testing and everything else. So I think that's interesting, and I think that is also something powered by nice, expressive Comptime metaprogramming and an appreciation for simplicity. So that's pretty much it. If you're interested, obviously go download Zig from the website if you haven't done so. One recommended view is the Road to Zig 1.0 by Andrew Kelly, especially if you're interested in the claim about Zig being better than C at using C libraries. Andrew gives quite a few more supporting arguments, supporting points in favor of that argument. If you start programming, really do consider joining a Zig community because the language is young, it's still subject to change. We don't have a ton of learning materials out there. We do have some. So on the website, you will find the Learn section with some interesting material. But we're not yet like huge as, I don't know, Java or like even Rust. So we're getting there. And asking in the community, it's like it's a quick way of getting unblocked in case you have problems. If you want to see more Zig stuff, check out Zig Showtime, my YouTube channel. I also run Zig News. It's like a blog posting platform, mostly for people who are too lazy to set up their own blog. But there are some interesting articles that you can read there about how to do stuff in Zig. As a reminder, the Zig Software Foundation is a non-profit foundation. So consider donating if you want to support the project. And that's pretty much it. Thank you very much. OK, so what should we do?
I think we have time for questions now,
okay.
And then I'll go check how the food is doing.
Yeah,
it's just outside.
It's just outside. Great.
OK, perfect. So any burning questions?
A reflection, like I spent five hours, and there wasn't much news in this talk, which is kind of impressive for just having spent 5 hours.
Nice.
And
yeah.
Your blog was read during that time.
Thank you. Yeah, I usually say to people who are trying to decide between trying out Rust and Zig, I always say to people, I don't know, try out Zig for a couple of days and then Rust for a couple of weeks and see which one you prefer. Yes?
Maybe one question on Comptime.
Yes.
How does it work in practice? Does it mean that there is like a first compilation producing like a binary, or is it interpreted and then you execute the comp type segment and then you run the compilation again? Or I'm oversimplifying here, but what is the general idea and mechanism behind it?
Yes. So you know what? I'll repeat the question for the recording. So the question is about how does Comptime work? The answer is that I guess the best answer is that it's interpreted. More specifically, Comptime is sandboxed. You cannot do I/O in Comptime, for example. The reason for that is because Comptime is meant to behave like the target machine. So if your target is, I don't know, you're on a little endian machine and your target is big endian, Comptime needs to run transparently whether you run it in a cross-compilation setting or on a native compilation setting. So that's why it cannot do I/O, it cannot do this kind of thing. Like, it's a design decision. We could have allowed it, but then it would not have been, there would have been a bunch of foot guns when it comes to cross-compilation, and that's one of the key points of Zig, like own all the platforms. So yeah, that's how it works. And more specifically, it's a step inside of semantic analysis. So I'm not an expert of like interpreters, but don't think of it as like a pure interpreter, which like, I don't know, you produce bytecode and then you run the bytecode into a generic like VM thing. It's intertwined in semantic analysis because it needs to be lazy. It needs to be very lazy so that you can have, for example, import cycles, things that reference one another. And every time, for example, a type gets explored in semantic analysis, only as needed, nothing else is forced evaluation, so that you can have, again, more self-referential stuff, which I don't know, maybe it doesn't sound nice the way I say it like this now, but it's very important in practice when you get stuff done.
That sounds very cool.
Yeah, it's amazing. When I saw it the first time, as an external, like I didn't know anybody, I just saw the website online one day. Man, the moment I saw Comptime, I said, like, okay, if you ask me in the past or like even today, my favorite language / family of languages would be Lisp, probably. I love metaprogramming for real. That's why I hate macros. And when I saw Comptime, I said, holy shit, yeah, that's how it was supposed to be all along. Why isn't it like this? So it really clicked for me right away. Yes?
What is the performance of Comptime compared to like Const Expert or?
Right. So Comptime is not great. It's slower than Python. So I don't know, like if you have a Fibonacci thing, I don't know specifically about Fibonacci because the Comptime is also memoized to some degree. But generally speaking, if you compare like a Python script versus a Zig script, when it comes to Comptime evaluation, right, not the real running executable, obviously Zig is going to win. But if you compare Comptime evaluation, Comptime today is slower than Python. Obviously, we want to improve on that, and shouldn't be impossible to achieve better performance. But yeah, Comptime, the idea is that you should not be, like if you're computing a, I don't know, gigantic table, it's probably a good idea to consider that a build step rather than part of Comptime evaluation. Like I guess there is a cutoff point where it's not worth it anymore. Yes?
Regarding making it a build step, how well is the build system handling non-SIG stuff? Is it made to have dependencies for header generation and compiling other languages and like having a complex pipeline?
Yeah, yeah, you can definitely have a complex pipeline. You can, you have the ability to run shell commands as an example. So you can, all it does is basically build a graph of steps that have to, run in the correct order. It also supports the ability of building part of like a subset of your code base as a build dependency that then produces header files or whatever you want. Today, I think we don't have yet a nice templating language in the standard library. So like if you want to generate header files and stuff, you might want to have like a nice templating system. We don't have that yet. So like there are some bits and pieces there that are not there yet. But the build system as a whole is not meant to have any limitation from that perspective. One last thing that I'll mention is that whenever you build something like an object file or like a shared library, and you export CA ABI compatible symbols, Zig is supposed to create the header file automatically for you. So you create your, I don't know, like static archive, whatever, and you also get the header file. So that it's easy to consume. This feature regressed in the past, but now that we switched to the self-hosted compiler, I think it either was already turned on, I haven't tested yet, or it will very soon. So that's also another thing that you can expect from Zig. Any other question? Yes?
Time for more questions or not?
Yeah.
I remember there was on the issue tracker,
Mm-hmm.
there is a proposition actually from on group, I believe, to change the way functions are declared, because everything is declared as
Yes.
some symbol
1717.
and to switch that,
Yes.
is it still considered or not, and why?
It's considered. I think it was accepted, and it lost the accepted flag because Andrew wasn't convinced anymore, and I think also the original sponsor, Stevie Hershu, also wasn't convinced anymore either. So I don't know. They're thinking about it. Although I would say that that's one thing. I think that sometimes people conflate, I'm not saying that you did, but just for clarity, some people sometimes conflate this alternative syntax for declaring functions with the ability to declare functions inside function bodies. That one is planned for sure. Whether it's going to be with so right now to do a function, you do function foo and then open parentheses, right? But the 1717 issue said to change it to const foo equals function. So basically make all functions quote unquote anonymous and then bind them to a variable with the name. It's just like a stylistic change. But we don't know if we're going to do that or not in the end. So up in the air for now. Yep. OK. Yes?
Would you like to explain inline for and inline switch?
Oh, well, inline switch is not really a thing, is it? It has inline else. Huh?
Inline else.
Inline else. Oh, man. Here's how I can explain inline else. I wrote a blog post about it. So my recommendation is, yeah, check this blog post. It's on Zig News. It's called Easy Interfaces with Zig. Long story short, like in line 4 allows the for loop to unroll, and Comptime uses duck typing a lot. So as long as the type of thing that you're passing in checks out syntactically, like well, not just syntactically, but like you can call a determinate particular method on it, or like you can do plus because it's a number, it's gonna work, unless you add extra reflection checks to maybe reject types that you don't like. In a similar vein, with inline else, which is a newer feature of Zig, you can basically create switch cases where every case is a different type, like in this code example here. Every case is a different type. But as long as all these types have a .talk method on them, you basically have the inline else. Think of it as unrolling, like expanding into cat case calling cat.talk, dog case calling dog.talk. And that's a nice shortcut in practice whenever you're doing a specific type of runtime polymorphism, doing interfaces. This is not, there are different types of interfaces where you do more complicated stuff, but like if you need to put inside an array a bunch of different things that you want to operate on them in a homogeneous way, you put them inside a union, and then somehow you need to bridge static dispatch with dynamic dispatch. So basically you need to switch on the runtime tag case of your union. And that's where the magic happens, and inline else helps save some keystrokes. Basically what you see here, so I hope everybody has taken in the code example, this basically becomes becomes this. It's like a shortcut for writing that. Obviously, the requirement is that both cat and dog have a .talk method. If they don't, then it's not going to work. But if they do, then you can use inline else. There's a few things like this that, if this is confusing, it's fine. You need to get your hands dirty with Comptime. Once you do, you will find that it's very natural the way it works. Or at least I don't know. It really clicked for me. But I do think that if you don't have actual hands-on experience, it's understandable if it's a little bit confusing.
I think we're time for one more question then we eat.
OK. Last question before eating.
Oh, no.
Any takers? OK, I have the question. What's for dinner? Let's go. Thank you.